Good afternoon, everyone. I'm Ben Baker from Juniper Networks, and welcome to part one of our three-part blockchain webinar series. Today we'll explore this clever new technology. We'll articulate exactly what it is and what problems it solves, and try to cut through the hype and really gauge its potential. In part two of the series, we'll assess blockchain opportunities and discuss how Juniper can help you as you experiment with blockchain. And finally, in part three, we'll narrow our focus and look at blockchain specifically in the context of network operators. And we'll have a special guest for this one to help us think through which use cases show the most promise. So let's jump right in. There's been a lot of commentary on blockchain in the last few years, and some of it pretty lofty. And actually, it seems to have ramped up exponentially, the commentary just in the last 12 months. Here's a few examples. According to Gartner, what they call the business value add of blockchain will exceed $3.1 trillion, and that's trillion by 2030. And I'm always a little skeptical of forecasts that go many years out like this one. IBM talks about blockchain vaporizing friction in economies. Mark Andreessen, now he's been right before about technology trends, so he's someone that we should listen to. He says that blockchain is what the internet has always needed but has never had. Others refer to blockchain as the internet of value, in contrast to the World Wide Web, which is the internet of information. And one of my favorites here, Melanie Swain in her book compares blockchain to the Magna Carta and the Rosetta Stone. So is all this real or is it hyperbole? Here's what Juniper believes are fundamental principles of blockchain, if you will. First of all, blockchain does not equal Bitcoin. Bitcoin is just one application, although it is by far the most mature, successful application. And I'll go a step further and say that blockchain is not just for payments, cryptocurrencies, or even only for the financial services industry. It's much, much bigger. Number two, blockchain fundamentally facilitates trust, ensures data integrity, and reduces transaction costs. So it has the potential to reshape the nature of, the organization of, not only supply chains, but also individual firms themselves. A lot of talk out there lately about the sharing economy, and blockchain can facilitate this and even further disintermediate value chains. Even disruptors like Airbnb, Uber are susceptible to a peer-to-peer technology like blockchain. And the trust at scale that blockchain delivers, it acts as a force that tends to reduce the power of large dominant companies. So it helps individuals and SMBs as well as other forms of ownership models such as cooperatives. Number three, the impact, the success of blockchain will depend in large part on the willingness and incentives of individuals and companies in a particular ecosystem to collaborate. So you have to look at not just the business case, what are the efficiencies, cost savings achieved with a blockchain solution, but also the presence of vested interests in a value chain, powerful intermediaries that might exist that might be resistant to change. Number four, we're in the early days. Most significant payoffs from blockchain are many years away, but for many companies, for many industries, now is the time to start experimenting. But virtually all blockchain projects that you hear about today are trials. Again, Bitcoin is the prime exception. And blockchain is a foundational technology, so it's hard to imagine what will be possible and successful. And don't think in terms of an overall blockchain strategy. Think about individual use cases. And finally, number five, the keys to success for blockchain start with aligning system design decisions and trade-offs with the needs of a particular use case. And it's a bit of a misconception that blockchain will solve all security issues. So it's very important that you run the application on secure networking infrastructure that's well orchestrated end-to-end, on fungible cloud infrastructure from Juniper, of course, and this holds whether you're using a public cloud, private cloud, or anything in between. Let me step back briefly and mention Juniper's vision of digital cohesion. And we define this as a future in which applications connect and self-assemble to deliver compelling megaservices that enhance our lives. And we explain the path to digital cohesion and Juniper's role in terms of four barriers to getting there that we are actively working on. And those barriers are interoperability, performance, economics, and trust. And blockchain certainly doesn't solve all of these problems, but it is an enabler, particularly in the area of trust. Okay, we've talked about blockchain at a high level. Let's look at exactly what it is and what problems it solves. Let's look at a supply chain today. And you can expand your idea of a supply chain here to think of any ecosystem where different vendors or other entities are transferring assets or sharing information. Each vendor needs a ledger, a database to record transactions. So let's say vendor A transfers an asset to vendor B. Vendor B needs to verify the authenticity of vendor A and of this transaction. Maybe vendor B sends a payment back to vendor A. The vendors need to reconcile the transaction, and often there's additional entities involved. For example, when a car is sold, government agencies need to track the vehicle title and registration. Insurance companies are also involved. So assets are held and traded both physically and electronically. We have a messy, complex web of mutual obligations, direct and indirect ownership, periodic settlements, and this is just a small glimpse of one aspect of one value chain for one industry. And think about magnifying these issues for larger ecosystems across borders, high-value asset transfers, etc. So supply chains and vendor ecosystems today are unnecessarily slow, costly to manage, very complex. Databases are replicated across participants, but there's little transparency and visibility, and you need tight security to maintain the integrity of the system. Now, what if you could have a single database that everyone in this ecosystem could see and make changes to? This would remove all the inefficiencies and complexities that we're talking about, but this would be chaos, right? How could you control access to this database? How would you verify that the transactions have in fact been executed? How would you maintain the integrity of the data? Blockchain can solve these problems. Let's revisit our supply chain, or more generically, our vendor ecosystem, but this time with blockchain, where we have a shared, distributed, decentralized ledger. With blockchain, trust is built in, or another way to put it is that blockchain essentially flips the idea of trust on its head and says, okay, two separate entities are never going to completely trust each other, but we take care of this with a transparent, auditable, traceable trail that's immutable, that is, you can't change it, and indelible, you can't delete it. And this is ensured through a consensus mechanism among all of the parties or all of the nodes in the system. By the way, in Bitcoin, this consensus mechanism, this process of verifying the blockchain is referred to as mining. So data integrity and provenance, attribution, what's the origin of the data, who's the owner of the data, are you sure about the identity of that entity that you're dealing with? All of these rules are built into the system. So you can remove intermediaries, eliminate duplication and replication of data, and overall increase efficiency and simplify the entire supply chain. And you still have many of those connections among different parties, but blockchain abstracts out that complexity and automates processes that today might be very clunky. Blockchain reduces compliance costs, transaction costs, and every industry has transactions, right? And think about how many parts of our daily lives involve transactions. So this is why there is fundamentally so much promise for blockchain. And let's take this a step further and bring up this idea of smart contracts. One of the real novelties of blockchain is that it's more than just a database. It can also set rules about a transaction that are tied to the transaction itself, in other words, business logic. This contrasts with a conventional database where rules are often set at the entire database level or in the application, but not in the transaction itself. A smart contract consists of code that can reside within a blockchain to automate processes. When they execute on every node. So the nodes do need some compute resources, for example, virtual machines or containers, and we'll get back to this point in part 2 of this webinar series. Now, in the world of IoT, for example, where the number of devices is massive and it's increasing exponentially, smart contracts that can automate, manage, verify the transactions and the communication among these devices might make new business models economically viable where they were not in the past. So here's an example. A container leaves the manufacturing plant, that's step 1 on the left side of this slide, reaches the neighboring port, Step 2, by road or railway, for example, gets transported to the destination port, number 3, and then to the distributor's facilities, number 4, and then finally to the retailer. And let's just blow up one of these handoffs from number 2 to number 3. And here the carrier, the shipping container, performs a handshake with the dock at the destination port, number 3, to confirm that the container is delivered to the expected location. Once that handshake is completed, it posts to a smart contract to sign the delivery. The destination port follows along to confirm reception. If the node at number 3 does not post to the contract within an acceptable time frame, the shipping carrier will know and then can initiate an investigation. The IEEE is a good paper about smart contracts and what's possible, so I'd recommend that. And on the right side of this slide, the potential benefits of smart contracts include low contract costs, enforcement costs, compliance costs. It may now become economically viable to form contracts over numerous low-value transactions, as I mentioned, especially with respect to IoT. But there are potential risks. First and foremost, the legal system needs to catch up here. A smart contract is not the same thing as a legal contract. Also, a reliance on an autonomous system that executes the contract can be a bit of a leap of faith. And at this point, the technology of smart contracts is still very much in its infancy, and we're some time away from widespread deployment. And by the way, the most well-known smart contract platform out there is probably Ethereum. And with that, I'll wrap up this first installment of our blockchain webinar series. We started with the hype around blockchain and then told you what Juniper's point of view is about this interesting new technology. And then we defined what blockchain is and what problems it solves and what it can enable. Thank you for your time, and stay tuned for part 2, where we further dig into the blockchain opportunity and discuss the role that Juniper plays.